Good afternoon everyone. So today's session I will discuss about an sum of subset problem. So last class I have explained you about what is a backtracking and all. So backtracking is a concept so where you will be finding the solution for a set of the solutions for an given problem, and in this backtracking concept initially we will start with one particular path and we will move on that particular path in order to find out the solution. If the solution is found, then we will backtrack and again we will try for the one more solution. So if when we will move on a one particular path and if the solution is not found, again we will backtrack and we will find it for the find for an solution. So what is the sum of subset problem is? So let us consider this is a given set of the element and this is the D. So sum of subset problem, we need to find out the subset of an given element such that the sum of the elements of those subsets should be equal to the D. So for example, if the set of the element are 1, 5, 2, 7, then what are the subset you can get so that the sum will be equal to the 8, that is 1, 2, 5 and the 1, 7. So that is about the sum of subset problem. So as I told you in the previous class, all your backtracking concepts will follow two type of the constraint. One is an explicit constraint, other one is an implicit constraint. So what is explicit constraint says here is the element what you are selecting in the subset should be one of the element in the given set. That is explicit constraint. So whatever the element you are selecting in the subset, it should be from the given set. So that is a explicit constraint. So now what is an implicit constraint? So implicit constraint says that whatever the elements you have taken in the subset, their sum should be equal to the D and the element should be ordered, that is ascending order in the subset. And one more thing is that none of the elements should be repeated. So that is an implicit constraint. So what is that implicit constraint says? Implicit constraint says that the sum should be equal to the D and they should be ordered and none of the elements should be repeated. So that is an implicit constraint. So that is about the explicit and the implicit constraints. So now you consider this how to write the solution. I told you in the previous class that all your backtracking concept will involve the construction of the solution space tree or a state space tree. What do you mean by a solution space tree or a state space tree? So solution is nothing but a one solution what you are getting, and solution space or the state space is nothing but the set of the solutions what you are having, and solution space tree is nothing but the tree that is used to represent the set of the solutions, that is called as a solution space tree. So now let us consider this particular example where the S is equal to this one. So before you will construct the solution space tree, arrange the elements in the ascending order. Don't forget to do that. So suppose if I try to construct the solution space tree for this, you may get the wrong answer. Therefore arrange them initially in the ascending order, then construct the solution space tree. So in this solution space tree, initially that is the root node represent none of the objects are selected, none of the elements are selected. So now whenever I'll move towards the left, it is with the element. Whenever we will move towards the right, it is a without an element. Got it? When I'll move towards the left with element and towards right is without an element. So first I'll move towards the left. So with 2. So when it is with 2, it is the total sum is now 2. Again with next element. So whenever I'll move towards left, it is with 6 is 8. Next element 8. So with 8, so 16. So that is what we wanted the solution. So now, so here with 2 means with 2, element 2. Now whenever I'll move towards right, it is without. Okay. Whenever I'll move towards left, it is with. Now I'll move here with 6 I wrote, so it is 8. Okay, now it is with and without. So when it is without, so it is without means what? The sum will be same only. It will not be a 16. Like if I'll move towards this side, it is with 8, it will become 16. But without means it is 8 only. 8 plus the next element. What it is? 14. So 8 plus 14 is greater than D. Okay, no need of continuing from here. We can stop here only. This will become a dead node. This will become a dead node. So now you consider from here. So with 2, okay, with 6, without 6. That is the second element. So without 6, your sum will be same, because I am not at all considering this element. I am not adding it. So sum will be previous sum only. Whatever is there in the root, same thing. Now with next element. Next element is 8. After 6, what you are having? 8 only, no? So with 8, without 8. So with 8 it is 10. Okay. Now 10 plus the next element is 14, which is greater than D. No need of continuing. Next, without 8. So without 8 is how much it is? So it will be same. Now next element 14. So with 14, without 14. So with 14 it is a solution, and without 14 it is 2 only. So 2 is less than 16. So I will not get the solution. Stop. Like that. So it is without 2. So it is with 2, without 2. So without 2 will be same. Sum will be same. Okay, current sum will be same. Now after first element, second element. With 6, without 6. With 6 it is 6. Okay. With 6 it is 6. Now without 6 it is previous 0 only. Now after 6, 8. With 8, without 8. So with 8 it is 14. With 8 it is 14. Without with 6 it is what is the third element? Okay, 8. So okay, with 8 it is 14. Without 8 it is previous only, 6 only. Now from here, so it is 14 plus next element. 14 plus next element is greater than D. Therefore no need of going further, you can stop. And here 6 plus next element is again greater than, what is your previous sum? 6. So 6 plus adding the next element is greater than D. So stop here, no need of continuing further. Now without the 6 I got 0 only, previous only. Now after 6 I am having 8. So with 8, without 8. So with 8 it will be 8. But 8 plus adding the next element is greater than D. Therefore no need of going further. And here without 8 is 0. 0 plus 14 is less than D. Okay. So it means I will not get the solution. No need of continuing here. No need of continuing when I am getting a dead vertex. So see here. So this is what we have written, the dead vertex, when we will get to the dead vertex. So if the current sum, take this example, the current sum is 8. S dash is 8. Current sum plus adding the next element. What is the next element? 14. So 8 plus 14. If it is greater than D, if it is greater than D, then it is considered as a dead vertex. Why? Because its sum will be too large. Therefore, it is considered as a dead vertex. Same thing here also. So what is the current sum? S dash 10. What is next element? 14. Because with 18 I have written. No. So what is the next element? 14. So 10 plus 14 is greater than D. No need of going further. It is a dead vertex. Okay, that is one dead vertex. One more case when I will get to the dead vertex. Sum till now, that is 0 plus adding rest of the elements. What are the rest of the element I am having with this? How much? It is 8 is over. The rest element is only 14. So 0 plus 14 is less than D. Therefore that will also be considered as a dead vertex. So in this case the sum will be too small. It is not too large. It make a correction here. It should be small. The sum is small. Therefore that will be considered as a dead vertex. So these are the two situations when you will come across the dead vertices. If the current sum plus including the next element, if it is greater than D, then it is a dead vertex. One more situation, the sum till now plus including all the rest of the elements. If its sum is less than D, then it will be considered as a dead vertex. So before this one, there are some of the assumptions also made in this sum of subset problem. So what are those assumptions are there? This one. Okay, what is this? Before I'll explain you the algorithm, these are the some of the assumptions that what we are making when we will be considering the sum of subset problem. So what is that assumption here is that these two are the assumptions. So here when I'll take a sum of all the elements of a given list, if it is less than D, if this condition not met means what? Less than D. If the sum of all of them is not equal to if it is an less than D, can I get a solution for that? No. Means what I am saying is, if I add all of this, assume that my D is equal to 100. If I'll add all of them, is I'll get the solution as a 100? No. Then the solution is not at all possible. If I'll consider a sum of all these elements, if it is less than the D, then you cannot find the solution for such type of the problem. That is one assumption. One more assumption is the first element. Anyhow, this we are ordering. No, as I told you before, I'll construct the solution space tree, I need to order them. Suppose if the first element is 16, obviously all these elements will be greater than 16. Correct? Then if the first element itself is a greater than D, will I get the solution? No, 100% I will not get the solution if the first element is greater than the D. So that is the two assumption what we have to check. That means always your first element should be an less than the D, and the sum of all the elements should be an greater than D. Then only I can get the solution. Otherwise it is not possible to get the solution. So this I have explained you. I'll take one more example. So here let us consider these are the element. It is not -7. It is 1, 5, 2, 7. Okay, some line was there. It is erased. Okay, first arrange them in the ascending order. 1, 2, 5, 7. So don't forget to arrange them in the ascending order. Now write the solution space tree for this one. So that is first element is 1. So with 1, without 1. So with 1 it will be an 1. Sum will be 1. Without 1 it will be 0. Next consider the second element. With 2, without 2. So with 2 will be 3. That is 2 plus 1, 3. And without will be the same parent node, whatever is there, that will be copied. Next element is 5. So with 5, without 5. So with 5 it will be 5 plus 3, that is 8. That is what the solution we want, that is 8. So we got the solution. Now without 5 the parent will be copied, that is 3. Now 3 plus the next element is 10. So that is 3 plus 7 will be 10, which is greater than D. Therefore I cannot get a solution here. Stop there. It will become a dead vertex. Now come here. With 2 we done. No, without 2. Without 2 will be same. Okay, 1 only. Now what is the next element? 5. So with 5, without 5. So with 5 it is 5 plus 1, 6. Now 6 plus the next element is 7, which is greater than D. So I can stop here. Now without 5 is 1. Now what is the next element? 7. So with 7 it is 8, which is nothing but the solution. Okay. Now without 7 it will be 1. So which is less than the D. Therefore here I cannot move. So it is stop here. Now without 1 is 0. Next element. So with 2, without 2. So with 2 will be an 2. Without 2 will be 0. Next 5. So with 5 it is 5 plus 2, 7. And 7 plus 7 next element is greater than D. You can consider it as a dead vertex. Now 2 without means 2. Then 2 plus 7 is 9, which is greater than the D. Therefore we can consider it as a dead vertex. Now without is 0. Now with next element, with 5, without 5. So with 5 how much it is? 5. 5 plus 7 is greater than D. Stop. then without 5 is 0. Now 0 plus 7 is less than the D, that is second condition. I told you, no, there are two cases you can find the dead vertex. So this is the second case and all these are the first cases. Then it will become a dead vertex, stop. So now in order to find out the solution, you travel from root to this. So root to this means with 1, with 1, with 5. So 1, 2, 5. So it is with 1, with 2, with 5. Okay. So one more solution is there. Again you travel from the root to this. So it is with 1, without 2, without 5, with 7. So it is 1 and 7. Wherever with is there, that one. Don't consider without. So it is with 1 and with 7. Therefore the solution vector here is 1 and 7. Okay, previous example also like that only you have to say. So solution is with 2, with 6, with 8. That is 2, 6, 8. 2, 6, 8 is one solution. One more solution is 2 without, with. So 14 plus 2. So it is 2, 14 is the one more solution. So like that you need to write the solution space tree. Okay, need to write the solution space tree and the solution vectors. So few more examples are there. You go through those examples. It is very easy only. Now I will move on to the algorithm part.